Hi there, this exercise 9b for Year 12 Maths, and we're looking at binomial coefficients, more basic looks at the binomial expansion that we saw last time and Pascal's triangle, and in particular, initially at least, the NCR button. Now the NCR button on a calculator, that's not a notation I've seen before. The way I would write it is 7C3. So I don't like this notation particularly, but this is, again, I don't like it, but this is very commonly used in exam questions, and it means 7C3. But personally, I always write it like this. Now notice the NCR button on your calculator, when you type in 7C3, it actually knows a formula, and it comes from this expression here. And you'll notice 7 here, so that tells you it's n factorial divided by, and it says 3, which is agreed with that, so that's r. 3 factorial, so in this case r factorial. And this 7 minus 3 factorial is n minus r factorial. Now I should point out this word factorial, if I write 3 factorial, that means 3 times 2 times 1. This is a new notation possibly. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So, and of course you can work these out. That's obviously 6. This is 6, 24, 100. I think this one's 720 from memory. So you can work these out, and there is actually a button on your calculator right in the middle of the screen in yellow, which works them out for you. We don't need them particularly, but I just thought I'd show you that formula approach. In the old days you would have to use this, but the calculators have got so good now, most of the times you don't need it. So anyway, expand and simplify the first 4 terms of this expression. Now when it's 6, we've seen before that the coefficients for the 6th one, if you draw out Pascal's triangle, you get 1, 6, 15, 20, 15, 6, 1. So it says the first 4 terms, so let's go with that. This is just a starter of what we've seen before, so it's one lot of the 3x to the 6, and I don't need to worry about the 2 over x, that's the 0. It says a plus, so they're all going to be pluses, plus 6 times by 3x to the 5, now times by 2 over x to the 1. I've got 15 lots of 3x to the 4, times by, what is it, 2 over x squared. Notice it's all squared though. All of these are all to the power, see that's why we put them in brackets. And the last term, the only one's 4. 20 times by 3x cubed times by 2 over x cubed. And now it's my job to simplify that here. So 3 to the 6. So notice I have to do these sums. You either know them, well, the probability is you don't, so you just type into your calculator. I've got 729. So this is 729 because I've done 3 to the 6, but notice I also need to do both of them, so x to the 6 as well. Plus, now I do 6 times 3 to the 5 times by 2 to the 1. So that is, I get 2916. Have I done that right? I'm just checking that again. 6 times 3 to the 5 times 2 to the 1. 2916, yeah, I did it right, I just didn't believe myself. 2916. Now again, just be careful, this is x to the 5, but then it's over x to the 1, and that's x to the 4. And notice it's gone down in 2s, we saw a similar example of this. Then from 15 times 3 to the 4 times by 2 squared. And I get 4860. And I know what's going to happen. This will be x squared, 642. The next one will be 20 times by 3 cubed times by 2 cubed. 4320. And that's x. Well, this actually, 642, you could write x to the 0, I suppose, but anything to the 0 is just on its own. So, and there it is, I just wrote it on its own. The other numbers do work good. So the example what I mean on this one then, the very first term is where we're playing with an expansion, but then we have to do something to it. And this is quite a common feature of a question. Notice my expansion's a nice one. I like these ones with a 1 at the start. They're more common than you'd think. So 1 plus 2x to the 6, it says. And of course, we just saw the first 3 coefficients are 1, 6, 15. So I'm going to use those. It's 1 times by 1 to the power of 6 times by 2x to the 0. And this is what I mean by this all becoming a lot simpler than it should really be. 6 times by 1 to the 5. I'm going to write these ones even though I don't really need to. 2x to the 1 plus 15 times by 1 to the 4 times by 2x squared. And you quickly get the answer for this, which is 1 plus 12x plus 60x squared. I think that's right. Now, notice it now wants me to multiply it by this. And because I've got this answer, I can do it quite easily. So part B is 1 minus x squared times by my last result, which was 1 plus 12x plus 60x squared. And assuming I've done that part right, this will be quite straightforward. 1 times by 1. 1 times by all of them, in fact. So I've done the 1s. Now I'm going to do the minus x times by all these things. And that will give me minus x minus 12x squared minus 60x to the 4. X cubed, sorry. Yeah, I made a mistake there. Yeah, everything else is right. And then lastly I'll do my x squared, well minus x squared times those. And that will give me minus x squared minus 12x cubed minus 60x to the 4. Now I have got x to the 4. So what if I was to multiply this out now? Notice I'm going to get 1 plus now 12x. I haven't got any other x's. I have 11x. And you'll notice, by the way, that I've deliberately done this, but I perhaps didn't need to do all this work. Come back to that idea in a bit. I've got 60x squared minus 12x squared, that's 48x squared, minus another one, that's plus 47x squared. X cubed, I've got minus 60, I reckon that's minus 72x cubed, and then finally minus 60x to the 4. I think I've got all the terms, but I might have made a dark mistake along the way. The important thing to notice is the actual question said find the coefficient of x squared. It didn't want all of this. So it begs the question, did I need to do it? And the answer is no, I could have just cherry-picked what I need. So for instance, there are 3 places where this came out with an x squared. 1, 2, where was the other one? Oh, there, 3. Now, if you think to yourself, the 1 has got to be times by 60x squared, so that's going to give me 60 of them. The minus x is going to be times by the plus 12x, that will give me minus 12 of them. And the minus x squared has got to be times by the 1, so that will give me minus 1 of them. So you could just straight away work out that it's going to be 47. And that's really what I want us to do. I don't want us to do all the work I just did, I just want us to go 47. So first of all, expand this 2 plus 4x to the 8, and it says do so for the first 3 terms. One way or another, again, because it's to the power of 8, you need to get the coefficients. And I just did on my calculator, I typed in n, or 8C0, 8C1, 8C2, and I've got these for the first 3 coefficients, 1, 8, 28. So based on that, part 1, I'm going to get 1 times by 2 to the 8 times by the 4x to the 0. It's got a plus, so they'll all be pluses. Plus 8 times 2 to the 7 times 4x to the 1. Plus 28 times by 2 to the 6 times by 4x squared, all squared of course. So what's that give me? It gives me 2 to the 8, which I think is the 256. Yep. So that's 256 plus 2 to the 7, which is 128. I've got times by the 8 and times by the 4. 4096. This time I get an x on that. And next time it will be an x squared. It will be 28 times 2 to the power of 6 times 4 squared. Don't forget that. 20, I typed it wrong. 28 times 2 to the 6 times 4 squared. I get 28,672 x squared. And then it says, hence, find the coefficient of x squared. And I'm going to do this, try and do this a bit quicker. So that gives me 2 minus 3x. I'm going to times that by the answer I just got, 256 plus 4096x. Of course, this last part relies on you having done the first part correctly, otherwise you're already losing marks. And how am I going to get x squared? Well, I'm going to do 2 times by that. I'm going to get 3x times by that. I think they're the only two ways of doing it. So this will give me 2 times by the 28672 plus a negative 3 times by, is it 4096? I get 45,056. And that's what they get, 45,056. Now notice I'm not actually that fussed about all the other bits. I just care about how many x squared terms I'm going to get. Next question. Expand this. And again, my how many terms do I want? It wants 4. My first 4 terms, I've got Pascal's triangle written down in front of me here, so I'm just going to write them down. They're my first 4 coefficients. So using those coefficients, part 1 will say it's 1 times by 1 to the power of 7 times by the half x to the 0. And this is one of those examples where you put that 1, it just becomes so easy. And the next one is 7 times by 1 to the 6 times by a half x to the 1. That's 1, 2, we need 2 more terms, 21 times by 1 to the 5. I could, of course, just not bother with the ones. I'm just writing it for completeness sake. Plus half x squared plus 35 times by 1 to the 4 times by a half x all cubed. So what's that give me? That gives me 1 plus 7 over 2x plus 21 over 4x squared plus 35 over 8x cubed. And that's done. Tick, done. Part 2 says now multiply it by this. So I've got to do 16 plus 8x minus 2x squared times by 1 plus 7 over 2x plus 21 over 4x squared plus 35 over 8x cubed. And it wants me to find the coefficient now of the x cubed. How would I get x cubed? Well, I could do 16 times by that. I could do 8x times by that, or minus 2x squared times by that. So if I do these 3 things, I get 16 times 35 over 8. That gives me 70. Then I would get 8 times by that. I think that gives me 42. So 8 times by 21 over 4 gives me 42. And then my last one is a minus a 2 times by 7 over 2, and that's obviously minus 7. So I think that's 105 when you do that. Let's see if that's the answer. 105. Good. So it worked out quite nicely. Now we've got this question, plus one more to do. I'll get this started. I don't think I'll get time to finish it. So it says we've got 2 plus kx to the 6. State the value of 8. Oh, right. So it tells me it's in this form. So if I do 2 plus kx to the 6, I will get this answer. I'll pause it and write them in. So there's my answer. And of course this can then be simplified. I'll write that answer in as well. Now of course they've said it's equal to this. And I've said it's equal to this. So straight away you can say the A and the 64 are equal. And then we can do a bit of other work to work out then what the K is and then what the value of A, B, C and D all are. But I'm going to save that for the lesson. And there's one other question as well I want to save in the lesson. And then you can basically see in class we'll do a mixture of exercise 9C and 9B. And we'll do another part of exercise 9C and 9B next time. But that's what we'll do in class. So thank you very much.